Let's do our own examples for a tangent function. So, let's see. Give me a number 0, no, greater than 0, no. Give me a number. 17, oh my gosh. We don't have room on our graph for 17. Give me either a fraction or 2, 3, 3, 3. That's a good one. Let's do x minus pi over 2. Plus 1. That's not on your paper, is it? Let me check. Perfect. What? No, it's not. Yeah. All right. So let's start with tangent of 0. So let's set x minus pi over 2 equal to 0. When we get, we'll go back to that. What does x equal? Pi over 2. Good. We add it to the other side, we get pi over 2. Now, if we have tangent of 0, what is the tangent of 0? 0 over 1, which is 0. So we get 3 times 0 plus 1, which is 1. So pi over 2, 1. All right. What do I set x minus pi over 2 equal to give me an asymptote? X minus pi over 2 to give me an asymptote for tangent. Asymptote has to be undefined. So where is tangent undefined on this unit circle? Pi over 2 and 3 pi over 2, right? So if you want to do your vertical asymptotes somewhere else, that's totally fine. You can keep them separate. So we know tangent of pi over 2 is undefined. And we know tangent of 3 pi over 2 is undefined, because they both make my denominator equal to 0. So let's set x minus pi over 2 equal to pi over 2. Add pi over 2 to the other side. What's pi over 2 plus pi over 2? Pi. It's 1/2 pi and 1/2 pi, which equals 1 pi. What else are we going to set x minus pi over 2 equal to? 3 pi over 2. Add pi over 2 to the other side. 3 pi over 2 plus pi over 2 is 4 pi over 2, which reduces to 2 pi. So these are vertical asymptotes. Let's go ahead and graph those. Oh. Yeah. No. Yeah. right, where else do I have a vertical asymptote? 0 and negative pi and 3 pi. All right. Now, you should know what your tangent function looks like. This is not a reflection. There's no negative out in front, but we do have this 3 that changes an amplitude. So we need to make sure we represent that properly. So let's set x minus pi over 2 equal to another increment. So we have 0, pi over 2 and 3 pi over 2. We never did pi over 4. So 0, pi over 4, pi over 2. What comes after pi over 2? For tangent, let's see, 0, pi over 4, pi over 2. We need to do 3 pi over 4. We need to do pi. Let's see if that's enough for us. All right. Pi over 4. Add pi over 2 to the other side. We need a common denominator. So this is actually 2 pi over 4. And we get 3 pi over 4. All right. I'm going to let you write that down for a second before we find the y value. We all understand that pi over 2 is equal to 2 pi over 4 if I multiply the numerator and denominator by 2. All right. Whatever's inside my parentheses, I just set equal to pi over 4. What's your tangent at pi over 4? 1. Tangent of pi over 4 is 1. So 3 times 1 is 3, plus 1 is 4. So 3 pi over 4, 4. You can see that the amplitude between, or the change in my y value between those 2 points is equal to what? 1, 2, 3. What do you think, where do you think the other point is going to be at? Wait a minute. What just happened? Oh yeah, because we did a translation. I haven't solved for x yet here. One of these, probably this one, we're going to solve and get, oh no, that would be a negative 1. We're going to have to eventually solve and get pi over 4, which would be in the opposite direction, so I'd have to set that equal to a negative number. But where could we predict it's going to land? Pi over 4, negative 2. Because my amplitude is still 1, 2, 3. This can go up and to the right. Down to the left. And then it just repeats. Make sure you're taking into account going from pi over 2, 1 to find your amplitude. This is your y equals 1 is your equilibrium. So like the middle portion. You don't want to go all the way down to negative 3 because that would be 4 apart. Some of you made that mistake on your homework when you tried to use the amplitude. Ooh. And draw that very nicely. All right. Questions?